What's up, guys? Let's kind of recap where we are in this current standard. So we should know how to simplify expressions. So we got times, power, power, times power. So it's all times and powers. So we got 2 times x times x. Well, that would be just 2 times x with a plus. So 1 times 4 is 4. And there's got to be 2 exponents to find on x. The one on the left would be 2 times 4, that's 8. Over here you just got an outside 5. So 8 plus 5 is 13. Those are both stay because they're both positives. And then we can simplify 2 to the 4th. 2 times 2 times 2 times 2, that's 16. Times x to the 13th power. Next problem, we have 5 to the 2nd times 5 to the 4th divided by 5 to the 8th. So on top of the bases, we got a 5 times a 5, which means we add the powers. Now on bottom, we have a 5 just with the 1 power. So we're going to have 2 plus 4 on top, and then 8 on bottom. Okay, now on top, 2 plus 4 makes 6. Now we want to cancel on the bottom. 6 and an 8. Now you can get rid of the one on the bottom, that's fine. I usually, when I'm not doing scientific notation, I usually get rid of the smaller one. So minus 6. Now if you did it the other way, you'd end up with a negative 2, which would have to be switched, but if it's down here, we wouldn't have to switch it. That's a stay. Now if you did it from up the other way, you'd have 5 to the negative 2 on top, which you'd have to switch to the bottom. Either way, it becomes 5 to the 2. Okay, 5 to the 2 is 5 times 5, that's 25. Put a 1 over it, so it's 1/25. Okay, next problem, we have 6. Remember with those times with fractions, you extend the line. So 6 times r to the 5th, and a 5th outside. 7 times r to the 10th with an x outside. So Hermson's operators are 6 times r on top, no repeats. 7 times r times x. So I don't put any plus signs, because there's 2 r's, but it goes from top to bottom. So 6 to the 1. And then the r, be 5 times 5 is 25. Then 7 to the 1, not in parentheses, so don't take 1 times 10, it's just 1. And then the r to the 10th. Then x, we apply a 1, but it's in parentheses, so we got to take 1 times 5 is 5. Now 7 I don't have on top, r I do, so I get rid of the one that's smaller, minus it, and it's 15. Okay, x can't be canceled. So those two are both stay. And those two are both stay. Stay on the bottom. Okay, 6 to the 1st is 6 times the variable r to the 15th power. Then 7 to the 1st is 7 times x to the 5th. Okay, my next problem. Times power times power, power times power. Underline it. So we only have top bases to start with. So 8 times x times y times x. When I get to that second x, I'm just adding in the first one. So let's do our 8. It's 1. 1 times negative 2 is negative 2. Then x, you have 1 on the left, a 6. 6 times negative 2 is negative 12. Then a 4 right there. So negative 12 plus 4 is negative 8. Then y, negative 3 times negative 2 is 6. That guy's got to switch, and it becomes 2. That guy's got to switch, so his exponent becomes 8. That guy stays, because he's already got a positive exponent. Okay. Then 8 to the 2nd can be evaluated. Nothing on top can be, but 8 times 8 would give us 64. Remember to simplify the exponent that you can. And there's this complete simplification. Okay, now, I didn't do a very good job explaining this yesterday, so I'm going to kind of review it again. Perform the operation. Make sure the answer is in scientific notation. There's that word, scientific notation. So 6 times 10 to the 4th times 4 times 10 to the 2nd. So it's all times. You got 4 things that are times. 1, 2, 3, 4. So I take the 6 times 4, because I can times any way I want, and then I take the 10 to the 4th times the 10 to the 2nd. So 6 times 4 is 24. Now you're going to want to put a decimal there, okay, at the end if it doesn't pop up. Then on the tens, 4 plus 2 is 6. Now bring that over here. Just write 24 decimal times 10 to the 6. Now, in the leading number, mark your first non-zero number. It's this one. The decimal has to be moved so it's right after that number. Well, right now it's not, so I need to move it so it is. So I moved it once to the left. Now look on the board, you 1, and you moved it to the left, so you're adding 1. So that's 7, so it's 2.4 times 10 to the 7. At the end of the answer, you should have 1 digit in front of the decimal, and it can't be a 0, okay? Next one, now division's the same way. Now it's just a division, okay? So we're going to first divide 1.5 by 5, then 10 to the 7th divided by 10 to the negative 2nd. So we divide here, we get 0.3, decimal shows up. Now cancel the bottom, okay? It was a negative 2, so you minus, not a 2, it's a negative 2. So 7 minus negative 2 is like 7 plus 2, which is 9. So 10 to the 9th. Bring that over here. 0.3 times 10 to the 9th. Now, find your first digit that's not a 0. It's 3. The decimal has to go after that number. You can't have just a 0 in front of it. You need one non-zero digit. So move it so it's after. Okay? So that's going to give us 3.0. I just put, if I need something to go after the decimal, I put 0, and I moved it once to the right. Well, that means minus 1 then in scientific, so that's 8. So times 10 to the 8th. Okay, now all you need to take into account from yesterday is know how to write a rational exponent in radical form. Radical form means I need this thing. Okay? So, what I do is I ditch the 2, make a radical over the whole thing because it's in parentheses, and put a 2 there. So that's my answer, radical 2, parentheses 4x. You can put the 1 power. If the power is a 1, you don't really need to put it, but I will. That's all I need. Okay, now you're writing a radical as a rational exponent. So you just have a base a to the 4th power. Now you underline the 4 and put a 5. That's a rational exponent. It's just a power with a fraction.